Alright, I think I got the microphone fixed just a bit. If you listen to the last set of notes, somehow my microphone settings got changed and it was like at full blast, and that's why it was being so annoying. So, rational expression. So basically what we're doing today, it's taking expressions, factoring, and then simplifying them, which mostly just is factoring practice. It's going to come up a little bit later though when we start doing graphing and stuff like that. So just some reminders. When you are multiplying things together, and by things I mean fractions, you're going straight across. So straight across. When you are dividing fractions, actually let's use some different letters. B, E, F, G, H divided by I, J, K, L. If you remember, you flip the second fraction. Why am I think I'm used to geometry. I'm going to erase that. I'm using way too many letters there. E over F, G over H. You flip the second fraction and you multiply straight across. Times H over G. So then you get E, H, F, G. But I'm sure, being as you guys are in pre-calc, you know and you remember that you should be flipping your fractions. Adding is a little bit different. So just remember, when you're adding or subtracting fractions, you need a common denominator. And multiplying and dividing is actually going to end up being simpler than adding and subtracting. So when you are multiplying or dividing and you're trying to simplify a rational expression, basically what's happening is you're taking fractions, minus 4 times x plus 2 over 16x. Right? You're trying to make this as simple as possible. You could just multiply straight across and you'd get a big mess, and then you'd have to try to do something with that. So your first step always in all of these is to try to factor everything that you can. In this one, 4x is literally just a 4x. You can't factor that at all. Same thing with 16x now. But this you can factor because that's a difference of squares. So you can change this into 4x, x plus 2, x minus 2, times x plus 2 over 16x. What you're going to try to do now is you're going to cross cancel. So you can cancel out factors. Top and bottom. And this is very important. Only when multiplying is involved. Involved. And basically what I mean, well, I'll show you what I mean by that in a little bit. It's like this x plus 2 and this x plus 2 can cancel out. Now you're going to multiply straight across, these turn into 1s. They don't disappear, they just turn into 1. So 4x times 1 equals 4x. And then you get x minus 2 times 16x is 16x, x minus 2. And then the last step is, can you simplify? Actually, I guess what I should have done also is, this is an x and this is an x. So really we just have 4 over 16. I was just going to do that at the end, but it makes more sense to do it then. 4 over 16 reduces to 1/4. So then you just get 1 over 4 x minus 2. And that's your answer. So you're literally just following these steps every time when they're multiplying. When you're dividing, you got to flip the second first. So let's just say flip second fraction first. But it's factor, cross cancel, simplify, basically every single time. So just to show you kind of what a division problem could look like. It's hard to think of these off the top of my head. Let's say you had x minus 4. I'm just doing an example problem exactly straight from the book. So if you look at the book for notes, you will recognize this. So first step, since it's a division, flip the second fraction. X minus 4, x squared minus 4 times x squared plus 5x plus 6 over x squared minus 3x minus 4. Now factor everything. I'm going to go horizontal just to save a little bit of room since I don't have to write these again. X minus 4 is just an x minus 4. Luckily we did this one up here. It's a difference of squares, so you have x plus 2, x minus 2. If you were to factor this next one, you'd get x plus 2, x plus 3, and on the bottom, x plus 1, x minus 4. Now you cross cancel anything that's the same on top and bottom. So x plus 2, x plus 2, x minus 4, x minus 4, and you end up with just an x plus 3 on top. And then on the bottom you have x minus 2, x plus 1, and you are done. Don't multiply this out. Don't do it. The whole point is to make this look as simple as possible. So once you've done that, you're finished. Okay. So adding and subtracting, like I said, a little bit more difficult just because you basically got to get common denominator, and there's a little bit more multiplying involved. So once again, I'm just going to take one from the book to start off with, and then I'll do another one. 3x minus 1 plus x plus 2. So what do they not have in common for common denominators, right? This has an x minus 1, this one has an x plus 2. So you're going to have to multiply this one by x plus 2 over x plus 2. This one by x minus 1 over x minus 1. Because you need these on the bottom to be the same. X plus 2, x minus 1. So once you multiply them like that, they're the exact same denominator. So you got to multiply the top. So you're going to get x times 3 is 3x. 2 times 3 is 6. Put that in parentheses, plus, parentheses, x times x is x squared. x times minus 1 is minus x. And on the bottom, x plus 2, x minus 1. Now on the top, you've got to combine the like terms, basically. This has an x squared, and it's a positive. And you always want to kind of put these in order. X squared. 3x plus negative x is 2x. And then a positive 6. The last thing to check is, could you factor that? And the answer to that is no. So that is your answer. Right? So on these kind of questions, factor, get common denominator by multiplying. You're going to combine like terms on top. And then you're going to ask yourself, can you factor and simplify? So let's do one that's a little bit more involved, where you have to actually, on that one we didn't have to do any factoring really at all. On this next one, we will. So 1 over x squared minus 1 minus 2 x plus 1 squared. So, is there anything factorable? This is a difference of squares. So it's going to be 1 over x plus 1, x minus 1, minus 2. And I'm just going to write this out twice because that's what squared means. And it's going to help us visualize a little bit in a second. So, we need these to be the same. This has 2x plus 1s. This one only has 1x plus 1. So, this one needs an extra x plus 1. This has now 2x plus 1s and x minus 1. This one is missing that x minus 1. So that's what I mean by, that's why you have to factor first, because instead of just multiplying this whole thing by this whole thing and this whole thing by that whole thing, by factoring we've just made it a little simpler. Now we'll multiply. You get x plus 1, because 1 times anything is itself, minus 2 times x is 2x, 2 times minus 1 is minus 2, all over the mess of x plus 1, x plus 1, x minus 1. Now we simplify. X minus 2x is negative x. 1 minus a negative 2 is a positive 3. X plus 1, x plus 1, x minus 1. And that's your answer. Nothing else is factorable. All right. And the last thing that I'm going to make you guys do has to do with radicals. We're going to skip the compound fractions, and it's called rationalizing. Well, I guess the question is, with our limited amount of time, sure, yeah. Rationalize a denominator, because this is going to become useful too once we have when we get a little bit farther. Basically what we're trying to do, the goal is to get rid of radicals in the denominator. As in 1 over 3 minus the square root of 2. We don't like having radicals in the denominator. Got to get rid of them. So basically what you're going to do is you're going to multiply top and bottom by its conjugate. Which is, you're going to change the plus or minus in the middle. So literally all you're going to do is look at that middle thing, look at this, and since that was a minus, this is going to be a plus. And there's some magic that happens. 1 times anything is itself, so you get 3 plus the square root of 2 over 3 times 3, 9. Now this is a difference of squares. This is a minus, this is a plus, but everything is the same. So what's happening is the middle is going to cancel out. If you do 3 times positive square root of 2, you get 3 square root of 2, but then in the middle you get negative 2 times 3 is negative 3 square root of 2. So, and then a square root of 2 times square root of 2 is a square root of 4, which is just 2. So the middle cancels out always. So really what we've got is 3 plus the square root of 2 over 9 minus 2 over 7. So this is important. That middle is always going to cancel out. So if you want to, you can just skip that step, which is what I usually do. I just do the 3 times 3 is 9, and then negative square root of 2 times square root of 2 is negative 2, which basically just the square root goes away. And you're always going to have a number on the bottom. Everybody's always going to have a bottom. And then the radical goes on top. So that is rationalizing a denominator. One other thing I just do want to note is that they have some pretty good tips for some mistakes to avoid in the book. The common error, if you look, is you have a plus b squared, and some people will just say it's a squared plus b squared. You've got to write it twice and multiply it out. Okay. The square root of a plus b isn't just separating them into separate square roots. That does not work. And this is where I'm saying, when I say a lot of stuff with multiplication and addition, you got to be careful with. No. Square root of a squared plus b squared is not just a plus b. There's a whole deal you'd have to do with that. 1 over a plus 1 over b does not equal 1 over a plus b. You'd have to get a common denominator. This is where I was saying you can only cancel out factors with multiplication. So see over on this side, the a's cancel out, leaving you just a b. You can't just say an a and an a cancel out and the b remains. It does not work with multiplication. So be very, very cognizant of that.